You probably think of plague as a disease of crowded medieval cities, rats scurrying in the gutters, Black Death paintings in a history textbook. That's not where it started. A study published this year found plague DNA in hunter-gatherers who died 5,500 years ago, thousands of years before cities, farms, or a single rat-infested street existed. The disease didn't wait for civilization. It was already here. Let's start with what the researchers actually found. A team led by Macleod, working at the time out of the University of Cambridge and now a research fellow at the University of Oxford, along with senior authors Eske Willerslev of the University of Copenhagen and Cambridge, and Martin Sikora, also of Copenhagen, examined ancient DNA pulled from the teeth of 46 people buried in 4 cemeteries along the Angora River near Lake Baikal in East Siberia. These weren't farmers. They weren't living in a city. They were small, mobile hunter-gatherer families, doing what hunter-gatherer families had done for tens of thousands of years, following game, moving with the seasons, staying close to the lake that gave the region its name. When the team sequenced the bacterial DNA still preserved in those ancient teeth, they found something nobody expected: Yersinia pestis, the exact bacterium responsible for the Black Death, in 18 of the 46 people. That's nearly 40%. For comparison, that infection rate is higher than some documented medieval plague burial sites, the ones we associate with packed, filthy, rat-infested cities. This outbreak happened in the middle of nowhere, far from any city, among people who had never seen a city in their lives. In one particularly striking case, researchers found plague DNA in an adolescent boy and girl buried together in the same grave, almost certainly siblings, taken by the same outbreak within days of each other. Here's where it gets stranger. Archaeologists studying these specific cemeteries had noticed something odd about them since the 1990s. An unusually large number of the dead were children and young teenagers, and many of the burials seemed to cluster tightly together in time, as if entire families had died within the same short window, rather than the slow, scattered pattern of ordinary deaths you'd expect across a normal population over decades. Nobody could explain the pattern. Was it warfare, famine, a single bad winter that hit multiple families at once? Then, the DNA gave them the answer. As archaeologist Andrzej Weber of the University of Alberta, who has led the excavation work at these sites as part of the long-running Baikal Archaeology project, the puzzle they'd been chasing since the 90s finally made sense once plague was identified as the cause. Radiocarbon dating showed that in some graves, siblings or parents and children appear to have died around the same time and were buried together. This wasn't a scattering of unlucky individual cases across centuries. It was rapid, family-based outbreaks, moving through small groups of people who lived, ate, and slept within arm's reach of each other. So why would this ancient version of the disease be capable of killing so many people so quickly, when scientists had long assumed early plague was relatively mild? For years, the working theory was that ancient strains of Yersinia pestis lacked the genetic tools that let later versions of the bacterium spread efficiently through fleas and rats, the mechanism behind the bubonic plague most people picture. That flea-adapted trait didn't fully develop until roughly 3,800 years ago, according to earlier genetic research, thousands of years after this outbreak. No flea transmission, the thinking went, meant a milder, slower-moving disease, one that could infect a person here or there, but couldn't tear through a whole community. The new genetic analysis complicates that. Researchers identified a distinctive toxin-producing gene in these ancient strains, called a superantigen, that isn't found in later historical versions of plague. Superantigens can trigger extremely aggressive immune responses in the body, the kind that can turn a bacterial infection into a fast, severe, and often fatal illness within days rather than weeks. According to senior author Martin Sikora at the University of Copenhagen, this ancient strain may have carried a uniquely dangerous combination of factors, lethal on its own, even without the flea-based transmission that made the Black Death so devastating thousands of years later. Which means the disease didn't need rats or crowded streets to become a killer in the first place. It only needed close, sustained contact between people, which a small hunting band, sharing a single fire and sleeping in a single shelter, provided every single night without fail. There's also a strong clue about where all of this began. The people in these cemeteries had documented close contact with marmots, large burrowing rodents that still carry plague bacteria in the wild today, in parts of Siberia and Central Asia. Marmot-to-human plague transmission is a well-documented risk even in the modern world, in regions where these animals are still hunted, which is part of why researchers were confident enough to trace the likely path here. Researchers believe the disease most likely jumped directly from an infected marmot to a human, probably through a bite, a scratch, or handling an infected carcass during a hunt, and then spread rapidly from that first person to their family and campmates. The study also adds weight to a broader theory that plague first emerged somewhere in Central or Northeast Asia, long before spreading outward across the rest of Eurasia through wild rodent populations, eventually reaching the rats and fleas that would carry it into medieval Europe thousands of years later. So put it together, piece by piece. Plague didn't require civilization to exist. It didn't need granaries stuffed with grain, attracting rats, attracting fleas, attracting disaster. All it needed was a wild rodent population carrying a dangerous bacterium and humans living in close, constant contact with each other and the animals around them. Hunter-gatherers checked both boxes just as easily as any medieval city ever did. The specific mechanism was different. The vulnerability was the same. And the stakes were not small. The Black Death of the 14th century, caused by a later, flea-adapted descendant of this exact bacterium, is estimated to have killed around 25 million people in Europe alone over roughly 5 years, wiping out something close to a third of the entire continent's population. This 5,500-year-old outbreak was smaller in scale, confined to a handful of families rather than a continent, but for the people living through it, the experience was strikingly similar. A threat that moved fast, hit the young hardest, and left almost no time to understand what was happening. This changes something important about how we usually tell the story of disease in human history. The common narrative goes like this. Humans lived healthy, isolated lives as hunter-gatherers, and then agriculture and cities came along and manufactured a whole new category of disease out of crowding, waste, and domesticated animals. That story isn't wrong exactly. Farming in cities absolutely did create new disease pressures later on, new opportunities for pathogens to jump from animals to people, and then spread efficiently once enough humans were packed close together. But this find shows that the raw ingredients for a lethal outbreak, close contact, animal exposure, and a bacterium already carrying dangerous genetic weapons, were sitting there in human life long before anyone built the first permanent structure. Small didn't mean safe. It just meant the outbreak stayed local instead of becoming a continent-spanning catastrophe. Which means the real story isn't that civilization invented mass death by disease. It's that our species has been vulnerable to it for as long as we've lived in groups small enough to trust and large enough to infect each other, which is to say, for as long as there have been humans at all. The rats and the crowded cities didn't create the danger. They just gave an old danger a new, more efficient way to travel, turning a threat that once wiped out a handful of families beside a lake into one capable of emptying entire cities centuries later. For a small group of families beside a Siberian lake 5,500 years ago, that danger arrived anyway, moving quietly from a marmot to a hunter, and then from that hunter to almost everyone he loved. No rats, no cities, no warning anyone could have understood, and no name for what was happening to them beyond watching their children get sick and not get better. Just the oldest vulnerability our species has ever carried, finally, after 5,500 years, giving up its secret in the DNA of a few dozen teeth.